Section 4, day 5 talks more about factoring quadratic expressions. It's a pretty big section because there's so much involved in factoring. So now they're going to start changing the directions to just factor completely. The first thing you should do, no matter what, is when the directions say factor completely, always find a GCF. Always. And then see what happens when you're done. So if you take a look at number 1, the GCF between an x cubed, a 2x squared, and the negative 8x is an x. And when I take that out, I'm left with an x squared plus 2x minus 8. So the tricky part about this lesson is what's left in parentheses, that x squared plus 2x minus 8, that can be factored further. So I'm looking for two numbers that multiply to negative 8 and add to 2. Two numbers that multiply to negative 8 and add to 2 are x plus 4, x minus 2. Multiply to negative 8 and add to 2. The biggest mistake I find is that students forget to copy down the GCF. So your final answer looks like this. It's a really good hint for you to double check if you have everything. If you count the number of x's, oops, that last one, it's funny, it should match the power in the beginning. So I have 3 x's in my answer, it has to be an x cubed. Taking a look at number 2, I'm going to repeat that same process. The GCF between a 2 and 18 and a 6, or 36, is a 2. Can't take any a's. When I take a 2 out, I'm left with a squared plus 9a plus 18. If you have 3 terms, a squared, 9a, 18, that's 1, 2, 3. When you have 3 terms, it's very important for you to look to see if it starts with a plain letter squared, in this case, an a squared. And if it does, you probably can factor further. So look for 2 numbers that multiply to 18 and add to 9. 2 numbers that multiply to 18 and add to 9. That's 6 and 3. So a plus 6, a plus 3. So again, the factor completely part means there's probably going to be a GCF. And when you take that GCF out, you can factor further. Number 3, the GCF between a 2, a 10, and an 8 is a 2. And I can also take an x. Each of those terms has an x in it. So I'm going to take a 2x out. I'm left with y squared minus 5. 10 divided by 2 is 5. Y plus 4. Look for 2 numbers that multiply to 4 and add to negative 5. The signs on this one are a little bit trickier because I'm multiplying to 4 and adding to negative 5. It's actually a minus 4 and a minus 1. Minus 4 times minus 1 is a positive 4, and when I add them, I get negative 5. All right, number 4. You never, ever, ever want your leading term, your highest power, in this case the x cubed, you don't want it to be negative. So here, not only am I going to take an x, I'm going to take a negative x out. That just changes all the signs and leaves me with a positive x squared and a positive 7x and a positive 10. The reason I'm doing that is because when I factor what I have left, and I want to find 2 numbers that multiply to 10 and add to 7, that only works when that first term is positive. If that were a negative x squared, I can't play that multiplies to the left and adds to the middle. But I can because this one is positive. 2 numbers that multiply to 10 and add to 7 are 5 and 2. So x plus 5, x plus 2. Don't forget to copy your GCF out front. So negative x times x plus 5, x plus 2. Factoring is really important. It's going to be the foundation of what we're going to be doing probably for the next couple of months because it's the rest of chapter 4 and most of chapter 5. So it's important that you know how to factor. Always look for a GCF first. Pause the video to do the you try it. I do want to point out here in this second you try it, you could have also written this as a 3AB and then just 2 copies of c plus 2. When those 2 factors match, you can write it as a quantity squared, but you don't have to. You do need to be able to recognize it, but you don't have to be able to write it.